Welcome to Accelerated Math. Find and use discriminants. Okay, this word discriminants. Let's talk a little bit about what that means. To discriminate means to, we hear it in a negative connotation a lot, but it means to, you hear about it in terms of discriminating against somebody's age or discriminating against their race or their ethnic background or something like that. Well, it means really to distinguish uh, about something about somebody. So to separate them because of a distinguishing characteristic. Okay, and in the quadratics, it may seem kind of a weird thing in math, but when you use the quadratic formula to find the two roots or the two x-intercepts of a quadratic or a parabola, I'm sorry, if this was a parabola, what you're finding is these two x-intercepts. Well, what distinguishes between these two values is this part in the formula is the plus or minus this b squared minus 4ac. So what we're going to look at is, first of all, the discriminant is called b squared minus 4ac because that's the part of the formula with the little plus or minus in front of it that distinguishes between the two roots. At the very end of the formula, you do plus or minus this, and the plus one may give this one and the minus one may give that one. So it distinguishes between the two roots. And they specifically, the discriminant is this portion. So the good news is we don't have to do the entire quadratic formula. We're only doing that one little piece. So what is this? Oh, yeah. Someone might say, well, you're very conservative, Mr. Fisher. You discriminate against people with tattoos on them. But let's see if we can find the discriminant there. There it is. B squared minus 4AC. It's a little crazy to have a tattoo on your back of your neck. The person behind you can cheat off of you. What are we going to plug in? Okay, going back to this quadratic, A, B, and C, these are our values that we're pulling out of the quadratic once it's set to 0. So make sure it gets set to 0 first. Okay, so I'm going to put those values in, B in over here, and then the A value and the C value right there. So I got B squared negative 2 squared. Notice I put that in parentheses because I want to make sure that I square it with the negative. A, 4 times A times the C value. And now I'm going to simplify this. Exponents first, so negative 2 squared is 4, minus 4 times 4 is 16, and then 16 times 5 is 80. Okay, so I've got 4 minus 80, or negative 76, because that came up negative. Now let's see. Oh, well, they're not asking that question here, but it is negative 76. All right. Now, some people might have thought that it includes the square root, and they might try to simplify it from there or whatever, but it does not include the square root. It's just the number under the square root once you simplify. All right, let's take a look. This one, it is set to 0, meaning it's in the standard form of a quadratic, so I'm going to have A, B, C values. Notice my A is 3. Notice there is no number associated with this right here, so I'm going to put a 1 in there because that's an understood 1 in front of that negative x, and then the positive 3 over here. So I got to make sure I get the signs. That's a critical part. B squared minus 4ac. B is negative 1 squared minus 4 times a, which is 3, times c, which is also 3. Now we're going to continue this. Negative 1 squared is 1 minus, notice I put the minus down there, then I do all the math here. All right, 4 times 3 is 12, times another 3 is 36. This one comes up negative 35. So the answer is this one. All right, they're trying to trick you in this here. It's not going to be the ones with the square root symbol on, so you can throw those out right away and then try to figure it out from there. Pretty easy stuff. Now, determine the nature of the roots. All right, I mentioned if you have a quadratic that when you graph it is in the shape of a parabola. I mentioned these x-intercepts, or I may have called them roots. They've got basically 4 names. X-intercepts, roots, they're known as those. They're known as solutions because they are the solutions when you do the quadratic formula, and they're noted as zeros because when you set it equal to 0, you get these answers, okay, or y is equal to 0 at those points. So we're interested, they're talking about the nature of the roots. Well, these are what we would call 2 unique real roots, meaning they cross the x-axis at real locations. If you have a parabola that comes down and hits it in one place like this, that is called one real root. Okay, so you've got one real root, two unequal real roots. That just means there are two specific real roots. And then finally, you might have a parabola that comes and never really touches the x-axis, and we're going to call that either no real roots, no real roots, or you might see it as two imaginary real roots, and that's when you have to solve it using the I in there. Okay, so let's take a look at this one and see what we get here. We got, again, label your A, B, C values, make sure it's set to 0 first, and then we're going to do the b squared minus 4ac. B is 24 squared minus 4 times a, which is 3, times c, which is 48. Got some big numbers here. 24 squared. I'm going to grab my calculator real quick here. Could do it in front of you, but anyway, 24 squared, of course, equals, I think I knew this, 576. Yeah, I work with square numbers a lot. 4 times 3, but I want to make sure because I'm doing this in front of you. 4 times 3 times 48 is also 576. Ooh, that's interesting. 576. So this is coming out to 0. When it's a 0, now think about the quadratic formula. Let's say that this one, if I put the whole quadratic formula, is negative 24 plus or minus the square root of 0 divided by 2a, which is 2 times 3 or 6. All right, negative 24 plus, well, what's the square root of 0? 0. Divided by 6. So this one comes out with a root of negative 4. Negative 24 minus 0 divided by 6. Well, minus 0 is the same as plus 0. They just cancel each other out, or they don't make any difference in the problem. Negative 24 divided by 6 is negative 4. Notice that I got the same answer under both conditions as plus or minus. So anytime you get a 0 in here under that square root, it is basically going to be, you're going to get two answers in the quadratic formula, but they're going to be the same. So we're going to call that one real root because it's not a unique solution. It's one real root. And the quadratic you would get out of that would look, well, something like this, because it would cross only at one place. It would touch, and you would have just one answer at negative 4. Let's say that's 1, 2, 3, 4. There it is. Okay, so it would look something like this one. All right. And let's go on. If we're going to get, let's see, A, B, and C, I got, B squared minus 4AC. It's already set to 0, so I'm just finding out what this comes out to. I've got negative 12 squared minus 4 times A, which is 3, times C, which is 12. Negative 12 squared is 144 minus 4 times 3 is 12, times another 12 is another 144. This is also coming out to 0. It's going to be a graph that looks something like, I'm not saying exactly, but something like this, where it's crossing at one particular location because it has a 0 for the discriminant portion. So it's not distinguishing between anything. It's one unique real solution. If it had come up negative, let's say it was 144 minus 288, and it came up negative under there, then it would be a parabola with two imaginary solutions, or you could say no real solutions. So just be aware of that. I don't know if I have an example like that or not. One more example. A, B, C, they're nice to us. They're putting all these equal to 0. I wish they'd mix that up a little bit. B squared minus 4AC. Stop it now and check, and you see if you can come up with the right answer, and then let this play once you finish. 2 squared minus 4 times A times C. That's 4 minus, well, I got 20 times 5 is 100. This is coming up to negative 96, which means it is going to be a parabola that comes and never touches the x-axis. It's going to be no real solutions. The other way they might have written that is two imaginary solutions, but they didn't this time. So, all right, have fun with that. Go use that discriminant, but don't discriminate.